So what makes Teslas pretty cool? One of the big things about Tesla is they have an extremely high fuel efficiency. They don't use fuel at all. Fuel efficiency is the ability for a car to go really, really far on 1 gallon of gas. The idea being the further you can go on 1 gallon of gas, the less gas you need to buy. And there is some data that suggests that using a lot of gas in cars can cause problems for the ozone hole layer, which we know can cause problems for us. So there are entrepreneurs out there like Elon Musk and others who are trying to develop super high efficient cars that can go really, really far on very little gas, or in some cases, no gas at all. The idea being we can potentially save the ozone and therefore save the earth. Well, let's look at a graph of fuel efficiency of cars and what that looks like. You're going to see this later today in class. So here is some cars that we have collected data on. About 20 to 30 cars that have different sizes or masses and the fuel efficiency of those cars. Now you can see here, these cars are very light. They're tiny, small cars, and they can go really far in a gallon of gas. They can go about 30 miles on 1 gallon of gas. But these heavier cars down here, they can only go about 15 miles on 1 gallon of gas. That means they have to go to the gas station a lot more. So it is important for lawmakers and automakers and scientists to be able to try to find out the relationship here. Well, the first obvious relationship is that the heavier the car, the less fuel efficient it is. But that's not enough. We need some numbers in order to understand this data to make better predictions. So how do we do that? Well, thankfully, you already know how to do this. We just need to apply it. So the first thing we're going to do is draw a line to fit, which we've already done. You guys are pretty good at that. The second thing we need to do is find the slope of this line and the y-intercept of this line, because this line, it's not enough to know it has a negative association. We need to know its actual slope and its actual y-intercept, because those are the numbers we're going to use to make accurate predictions. So how do we find slope? Well, the first thing is we want to make sure we're finding the slope of the line and not of any random points, because it's not enough to have 2 data points. We need a lot of points. So we're going to pick 2 points from our line and not our data. So I'm going to pick these 2 points. And it looks to me like this first point, we're going to call about 638. 600 is the X value, 38 is the Y value, meaning a car that's about 600 kilograms can go about 38 miles on just 1 gallon of gas. However, this point down here, this looks like it's about 2,700 or 2,800, we'll call it 2,800 on the x-axis and maybe about 6 on the y-axis, meaning a car that's 2,800 kilograms can only go 6 miles on the same gallon of gas. All right, now that I have my 2 points, I know how to find the slope. I know that I'm going to do rise and run. Now, thankfully, we have a calculator here because these numbers are going to get a little crazy, but that's okay. These are real numbers. So my rise first, I want to be able to know the difference in fuel efficiency. Well, that's my Y values. So I'm going to do 38 minus 6. And I know that's going to be, what's that, 22. So there's a change in Y of 22. So this is a change of 22. Now my x-axis is the change in car mass, so how big the car is. So that looks like it goes from 600 to 2,800, and that's going to be a negative 2,200. Well, what does that mean? That means my change in Y is 22, and my change in X would be a negative 2,200. Now, you could put the negative here if you wanted and the positive here, but the idea is that one of those numbers is negative, meaning the overall slope is going to be negative. So what is my rise over my run? My rise equals 22, and my run equals negative 2200. All right. So now I'm going to do 22 divided by 2200. That's going to be a very, very small decimal. And I did my math, and it's about 0.01. We're going to call it about 0.01 is my slope. And that's going to be negative. It's going to be negative because it is going down, meaning that for every 22 miles per gallon, I lose 22 miles per gallon every time that I increase the car 2,200 kilograms. In other words, I lose 0.1 miles per gallon for every 1 kilogram. So there's my slope, negative 0.01. That means that it's decreasing a tiny, tiny bit every time I add 1 kilogram to the car. Well, now I need the y-intercept. Well, here I'm halfway there, right? I got negative 0.01. You might get a slightly different number, but it should be around there, okay? Then I need my b value. Well, my b value I can just read from here. It looks like it's maybe about 47. So once I have this equation, now I can plug in any car that I want. Maybe I'm going to make a car that's 5,000 kilograms, like a truck or something. I could put that in here and figure out what is the fuel efficiency of that truck. Maybe I'm going to try to make a super, super light car, maybe like 200 kilograms somehow. All right, well, I can plug that in for X and find out what is the fuel efficiency of that car. So this equation, once I have these numbers, the slope and the y-intercept of this line to fit, I can predict the fuel efficiency of any car.